Welcome back to the Excite training videos. In this one, we're going to talk about how to use the Linux command line tools. Okay, so in the previous one, we talked about how to connect to a remote server, and we got to the point where with a graphical environment, we could run some standard desktop tools, um, or we could have a command line session through the graphical environment. We also talked about if you're using SSH for character-based access to the machines, then you're definitely going to be using command line tools. So that's what we're going to be looking at is what some of those available tools are, how to use them, how they work, a little bit about, talk just the tiniest bit about their design philosophy. And so let's dive in here. I'm going to log in using SSH again, like we did last time. So that's when I can remember how to type. Scott and X21 dot. Typed everything right. Good. Put my password in, and it's going to say, okay, you've got to authenticate yourself some other way besides just that password. I'll let it send a push notification to my phone. And I'll click on the green check mark, tell it it's okay. And I'm logged in. All right, so I'm connected to LNX 201. And very first thing I'm going to do is use the ls command. Right here, ls. It means list the files and directories that are available. And let's list them out and see what's there. Um, These are color coded. Actually, it might be a little hard to tell depending on what device you're using. They're color coded based on whether what we're looking at is a directory or a file or what Windows would call a shortcut, an alternative name. So a single file can have more than one name. Um, if you don't know what the color coding is, or if you're like me, I'm not color blind. I have to squint a lot sometimes to tell what colors are. Um, you can do ls space dash L, and that says, give me a listing of the files, ls, but give it to me in long format. Okay, the dash L, long format. It gives you more information. Um, so I can look at these and any one of these, I'll just go ahead and mention any one of these attributes over here. If the very first character is a D, it's a directory. Um, if it's an L, it's one of those shortcuts, like Windows would call it. It's a link. It's a way of letting a file have more than one name or letting a directory have more than one name. What we've got here, what you're going to see when you first log in is going to be very, very similar to this. You're going to have several directories off of your home directory. It's a good idea to organize work into directories. Makes it tremendously easier to find what you're doing later. So in fact, let's just play around a little bit and see how that works. So right now, I'm in my home directory. I can show that, but I can use the pwd present working directory command. Pwd, and it says, oh, you're in slash home slash escott, okay, or whatever your username is. Um, this initial slash means, okay, start at the very top of the hierarchy and step down in, and immediately right at the very top is a directory called home. And inside that directory is a directory called escott. That is my home directory. All right. So your home directory will be slash home slash whatever your username is. All right. Well, let's change what directory I'm in. I'm in home escott, my home directory right now. And there's a directory right here, documents. Why don't I change directory, go into there and see what's in there. So I type CD documents. I don't need that closing. Yeah. If I type CD documents, and I'll just warn you, this capital D is actually important. Unix file names are case sensitive. Uppercase and lowercase, they're different. It matters. All right. So I'll CD into documents, do an ls just to see if there's anything in there. And I've got a directory called Wolfram Mathematica, happens to be sitting there. That's left over from when I ran the Mathematica example. You likely won't have anything there the first time you log in um, unless you started Mathematica the first time. Um, let's put another file here. Let's put a file here that we can have to play with and manipulate. Several ways to create a file. An easy one is to use a text editor and just type a few things that go into it. There are a lot of different text editors available on here. Which one to use is a topic that nerds love to debate to no end. I have my own opinion, but also use nano sometimes. Linux comes with nano installed, and as the name implies, it is a very, very small, compact little editor. Um, it doesn't do a whole lot, but it's very easy to use. And that, you know, I give it points for that. Let's do nano first file.txt. All right, nice little file. When we're ready to save the file, the commands are across the bottom. One we're interested in, first one we want to do is write out because they're using S for something else, so they call it write out. And that is Control O. Hold down Control and hit O. And when it's creating a file, it'll verify, is this, you want me to write this name, right? You want me to create this file? Hit return. There you go. Okay, we did it. We saved it. We can exit now. The Control X key will exit Nano. So that's all there was to starting up an editor and editing our first file. Let's see what we have here. LS, we have, the Wolfram Mathematica directory we had before. We have first file.txt. Let's take a look here. I'm going to do ls-l, get a long form listing. And when you look at it, first file.txt, there is a dash at this very beginning. There is not a D, so it's not a directory. No L, it's not a link. So that means it's a plain file. It's just a plain old file, first file.txt. We want to see what's in it. Let's do that. The command cat is short for concatenate, and there's a reason, but we're only going to use one file at a time for a little while. So we'll just keep it simple and say that cat takes the contents of a file and types it out to the terminal. Did that work with? Hmm. Network just blipped on me. Okay, let me do this for real. Cat first file.txt. There it is. Okay, that's the contents of the file that I just typed. And okay. Um, so let's see. I am in my documents directory. I want to go back to my home directory. There are two or three different ways I can do that. if I'm going to my home directory, just CD by itself, CD for change directory, type CD, hit return, and now I'm back in my home directory. Okay, there's that home directory again. Let's make a directory we can use to play around, do a little bit of work in. mkdir, short for make directory. I'm going to make one called explore, just because, we're exploring. See the new explore. Let's see if there's anything here. Nope, zero. We just created that directory, so there's nothing in it. That makes sense. Since we're in Explorer, let's create a directory called play, ls-l. Okay, so we see play is here, and we know it's a directory. These these attribute bits indicators. First one is a D, so we know it's got to be a directory. I can CD into that directory. Let's see where we are. PWD, present working directory. I'm in /home/escot. That was my home directory. /explore, created that. /play. We created that after we went into explore. So we're 4 levels down from the top in a directory that we just created. Make another file. Another one. Save it. Okay. So now we got sample.txt. All right. We'll do a long format listing. It shows me a little bit of information about each file. Some attributes, like whether or not it's a directory or a file. Who owns it? Okay, that's my username. What group I'm in. Okay, so I'm in the chess group. The date and time that the file was last modified, which is, approximately right now. And the file name. Okay, it does this for all the files that you would normally want to see. You're allowed to hide is almost too strong a word. If a file name begins with a dot, then it's not going to normally show up when you do ls. It's not like it's going to hide it from anybody, but it keeps you from having to look at it and have visual clutter in your brain if you don't want to have to keep track of files that don't make a whole lot of sense. If I do ls-al, then that tells it that I want to do a listing of all the files, whether they have a period or not, and long format. When I do that, I'm going to see 2 directories in here that don't normally show up, but they're present in every directory. Every directory contains a directory named dot, which is actually the directory that you're in right now. That is a way of referring to the current directory. And sometimes it's useful. We'll see that right near the end. And there's another directory entry, dot, and that means the directory above me. So no matter what directory I'm in, okay, so I'm in Home Scott Explorer Play, whatever directory I'm in, CD space dot dot takes me one level up. Okay. So I went from Home Scott Explorer Play up to Home Scott Explorer. I went up one level when I did that. Okay. So I can make a directory called work. All right. We got two directories here. I can remove that directory, rmdir, and then space and the directory name removes a directory. Now, if I want to remove the directory play, I do that. Ooh, I get an error message. It very helpfully said, that directory is not empty. That is probably maybe not what you meant to do. So it stops, it refuses, rmdir refuses to remove a directory unless it's empty. All right, so that can come in pretty handy. Don't count on it. I mean, yeah, it'll work, but bad habit to get into, I suppose. But that's the kind of thing that, yeah, it will watch out for you sometimes. So, all right. Let's see. I'm going to go back to my home directory. Let's see where we're going. Network. There we go. CD, went to my home directory, and indeed, I'm in home eScott. Let's move around a little bit more. I can with CD, I can give I can give a longer path name that involves more than one directory, right? So I'm going to CD into explore one level down slash play another level down below that when we created that play directory. Okay, and that puts us in Home Scott Explore Play. Let's see. Back to my home directory. If I'm in my home directory, what happens if I do cd dot dot? It's going to take me up one level, right? So now I'm at slash home. Where we're going to find slash home, a little bit over 5,000 directories of yeah, that's a lot of directories. I'm in here somewhere, because I mean we know we've already seen me do a PWD and seen that I'm in here. Let's go up one more. Now I'm at slash. I'm at the top of the pile. And of all the things at the top level directory, they're all directories. Directories are a couple of shortcuts. In here, we see things like, oh, okay, so at this very top, there's home. There's a few other things. Slash bin holds holds a good collection of the programs that we actually use when we're interacting with the command line. The most of this is the operating system, and things that we probably won't really be dealing with much. Slash etc slash etc is some configuration information for the computer. It's interesting stuff if you want to learn about it. Not the kind of thing you need immediately to start running programs, but fun to explore. Um, Linux has enough security set up around it so you can explore things and see how do they work. And you don't have to worry about breaking anything because your accounts aren't set up to allow you to make changes, make mm, potentially damaging changes to the system. So you really don't have to worry about anything. You're not gonna make a mess. So let's CD back to that play directory that we created. Right. So that gets us there. Um, and in there we have sample.txt. Just kind of recap what we had going on. Let's go up to Explorer. Hmm. So I've created a file called things.txt. That's in home escot explorer. That directory contains things.txt and another directory called play. So play is a subdirectory going below there. Um, the cat will show us what's in a file, or I can cat // and that says, just like we did cd to say, let's go up. In this case, it's telling the command cat, I want you to open the file that you get when you go up one directory slash things.txt. Okay. So that's saying not in the current directory, but in the one above it. There they are. Okay. So it's able to print that out. We have a file in here. We're at the play level, sample.txt. That's what we have here. Two files. I just did a copy, CP copy, sample.txt to other.txt. So I took that too long file sample.txt and made a copy of it named other.txt. Have you noticed a pattern in a lot of these commands? A lot of them have two letters, both consonants. Unix and Linux is a Unix variant. Unix came out of a group of researchers at Bell Labs in the 1970s. Uh, First public release was late 1973. I don't think I don't think very many people outside of Bell Labs knew about it until probably 74 or 75. Um, they were really into information theory, and part of that concerns efficiently coding information for transmission. Um, and so, it's sort of a little party game of theirs, I guess. In the English language, vowels convey very, very little information. In English, you can take out all the vowels and you can pretty much still read it. Um, and it doesn't take a whole lot of letters to get an idea across with simple words anyway. And it turns out if you take the first two consonants out of a word, you can quite often it's unique enough to be useful. And so a great many Unix commands when you're trying to figure out why are they these ridiculous two-letter abbreviations. It's just the first two consonants out of whatever they're referring to. So CP is copy. We'll see some others. We've seen some others as already. LS, list the files. LS. This will we'll keep saying this. Um, we can, for instance, if we want to rename a file, um, we can use the move command, MV for move. We can move other.txt to fun.txt. And so now we other.txt became fun.txt. With move, the reason it has its name, if you're just in one directory, then it has the effect of renaming. But if you specify another directory, then it doesn't just rename it, it actually causes the file to move where it is. For instance, I could move fun.txt dot dot, tell it to go up one level. Okay, so now it's disappeared, sample.txt. I go up a level and oh, there it is, right? So there's fun.txt again. So MV move is also how you rename a file. You just move it to another name in the same directory. Let's see. Look at the notes here. Back to my home directory. A sometimes useful command is it did a lot of scrolling there. I'm gonna scroll back. So tree will list out all the directories and files in a somewhat graphical manner. I find that when I'm dealing with a really large um, hierarchy of files and directories, sometimes it's actually useful to be able to print them out this way. And you'll get as you use it, you'll get some experience. You'll get an idea of when this kind of display is useful to you versus when you want to use, just conventional LS and PWD. You'll kind of get a feel for it. I want you to be aware that tree exists, so you have it. You have it in your tool bag. Um, if it's the kind of thing you need, then it's good to have it. So let's look at some tools to make working with a little bit larger files a little bit easier. So for some fairly modest, um, uh, there's a fairly modest amount of information is available just to play with in a file that every Linux system has, and it has the intimidating sounding name in a sense of slash etc, etc. Uh, password, PASSWD. Now it sounds like this is going to be really dangerous, right? Like, oh man, here's the system configuration file. And it's got a bunch of passwords in it. And decades ago, it would have contained, at least it would have contained encrypted passwords. It doesn't even do that anymore. The file name at this point is a legacy holdout. But it is a little bit of information about some of the built-in accounts um, um, for that are necessary for the system to operate. How we're connected here the session's connected through SSH. One of the built-in usernames, SSHD, is used to operate the apparatus that makes that work. So as you look through here, you can kind of find some things and maybe start to explore from there. Um, we'll use this as an example of how to do a few other things. Something that is one of the first things we notice is that there were a lot of things in this file. There were a lot of lines in this file, and they scrolled by pretty quickly. Now, we've got scroll bars in Mac terminal window. We've got I think the Windows one has a similar thing. I don't actually use Windows that much. But even then, there's a limit to how much it can scroll back. So it's probably a good idea to have an idea of a command called more. And more is like cat, except it stops every screenful and waits for you to press spacebar to go to the next screen. Right. So it just printed, I think 23 lines of the first 23 lines of whatever was in there, and it said, there's more available. I've shown you 36% of it already. Okay, hit spacebar. Okay, now we're up to having seen 78% of it, right? So every time I hit the spacebar, it gives me another screen full. It moves a screen at a time. And that is very, very useful. Now, sometimes if I've got a really big file and I have an idea of what I'm looking for, I might want to start to zero in on particular ranges of lines. So one useful command is head. And that shows me the first few lines of a file. If I give it the option head, let's see, what do I have on there, -8, that's give me the first 8 lines. Okay, so that gives me only the first 8 lines. There's the head command. Here are the ones that it put out. Okay, similarly, there's tail. Okay, so the tail -3 gives me the last 3 lines. So you can see how if you had a large output file from a process, this would be a way to let you sort of step your way through. I'll mention that more for a page at a time. There is another pager called less, whose description is less is more, only better. With less, when it reaches a particular point, you can hit spacebar to move forward. You can hit B to move backwards. That's one of its great things is that it can page backwards. Um, yeah, I use it sometimes. Most of the time I use more, honestly. It's just force of habit. But use whichever one works better for you. Now, I've been typing file names here. And it's the file names I've been using aren't too long. I don't have incredibly long descriptive names I have to deal with. I'm not in a situation where I haven't been in a situation where I needed to search for things in particular. But let's take a look at how to deal with um, more unwieldy situations with file names. Um, so the directory user bin contains a huge number of files, easily over a couple thousand. I'm not sure how many, but I know there's a good number. let's see. Um, Aki's user bin. I want to see everything in user bin that starts with, say, ZIP. All right, let's see them all. So I've got user bin ZIP asterisk. Okay, that is a wildcard character. That means I want you to match every file name that starts with ZIP and contains anything else, or is just ZIP. So if I do that, ls, then that shows me, oh, here's the 7 files that match that. I could do um, oh, there's some command and I know there's these settings commands in there that let me, set up things, but I can't remember which one I want. So let me do a listing of every file in user bin that starts with anything. I don't care what it starts with, eh, or even could even be empty, and then has settings, and then has anything else on the end. Okay, optionally anything else on the end. So star settings star matches any file name that contains the word settings in it. All right. And wow, that's actually quite a lot of settings tools. These, by the way, are usable if you have a desktop session like No Machine. These are not ones we would use from the command line. So all those commands in user bin, wait a minute. Hold on. Does that mean, huh? So ls is in user bin. Hmm. That means that this command is it's a program. Hmm. When I type ls, it's not something built into the system that's interpreting that and printing out the files in a directory. It's just running a program called ls and then maybe reading whatever command line arguments there are, or maybe not. And ls, oh, okay. Interesting. So PWD is the same way. They're programs. Interesting. So I could use the command file, which tells me what kind of file something is. It tells me, oh, well, that's a lot more information than I thought I wanted, but here's the relevant word. That's an executable file. It is compiled machine language code. That's like a Windows.exe or the underlying application of a Mac OS.app file. Um, I kind of shook my head back and forth and made a funny gesture when I said Mac OS app file because they're not just files. If you've dealt with a Mac for a while, then you probably have seen, oh, okay, they're actually kind of special things. Um, but when you see this, you know that you're dealing with a compiled runnable program, which is okay. So that's how these commands work. Um, so if I said uh, which, tell me which file implements the more commands, like, oh well, yeah, it's user bin more. Okay. Um, well, that makes sense. So I guess CD, is that a program of its own? Hmm, interesting. I wonder how it did that. We'll have to figure that out. Okay. Um, yeah. Let's see. Wildcards. I'm looking at my notes here, so I don't do anything twice. Um, yep, 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 yep. Mhm. Yeah. Okay. Let's take another look here. That's a lot of stuff. I did ls-la, um, ls-al and -la. It doesn't matter what order the two options are in. It does the same thing. Um, and this is in a home directory. So I did in my home directory, I did ls-la, and that's showing me a lot more files than we would normally see, right? We type ls, we see desktop, we see class shortcuts, bin, that kind of thing. But we don't see this bash profile, bash RC, um, some of this configuration files and directories and stuff. There's a lot of things in here. Um, but, like we said before, there's dot dot, which refers to the directory above, and there's dot, which refers to this directory, self-referential, the name of the directory that you're in. You can always say dot, and it will always refer to the directory that you are in. That's relevant when things happen, and you're looking for, for instance, the fond command for traversing a directory hierarchy and usually printing out where you would find a file. It's for searching for files. Um, Fond, you have to tell it what directory to start from, and dot by itself is the current directory. So fond dot uh, dash name, was it sample.txt? Yep. And that tells it, okay, start of the current directory and find anything from here down named sample.txt. And it prints out and says, okay, starting at the current directory and explore play sample.txt. Found it right there. It matched. All right. So this dot to refer to the current directory. Um, this is probably the fond command is probably where you will use that the most. It may be, I mean, honestly, it may be the only place you use it, depending on how many how many commands you use, because this is such a common thing to do and such a useful thing to do um, for finding where you left things. Um, if we can find a file with the find command, it would be nice to be able to locate particular lines of a file that contain um, some string. So that's where we get the grep command. Um, and we can tell grep, okay, grep, I want to find uh, every instance of the string operator in the file etc password. It says, okay, I found one of them. That's what that line looks like there. Um, okay, so if I grep for LP in the password file, two lines match, right? So there's an entry for LP, and then there's a matching line on this one, Flatpak, user for Flatpak system helper. Helper contains the letters LP. So that's, kind of surprising to some people at first. Um, grep isn't, by default, grep isn't going to look for a word with spaces around it. It's just going to say, look, if I find these two characters in a row, um, yeah, I'm going to print that line out matching. Okay. Grep's got a lot of options. It's worth understanding how to use them. And for that, it's really useful to know how to find information on a command. Um, so one way is, fire up your browser and do some Googling. If you search for Linux grep, you're going to find hundreds of thousands of pages. most of which are duplicates, but a ton of information. If you just want a really fast reference online, um, there is a command called man, which is short for manual, and it will print out the manual page for whatever you ask for in the next argument. So man grep, and oh, there we go. And it's even piping it through more for us. I think it's piping it through less, right? So, oh, here are command line options for it. Yeah, all kinds of things, right? So gobs and gobs and gobs of options. You can read this and try to figure it out and do some Googling and ask your friends. And pretty soon you'll understand everything there is. I'll press Q and quit that and the instructions into the bottom. And let's do a little bit more. Okay, back at my home directory. Um, let's see how much. This ought to be a lot of lines. ls-l/home. This is taking a little bit of time. Oh yeah, yeah. See, it scrolled a while, and it's a fairly fast connection. So there was a lot of stuff there. Um, let's take all that and save the results of this ls. All right, so ls/home. I'm going to do this greater than symbol. Read it like an arrow saying, let's take the output of that and stuff that output into in my home directory. So I'll put it in people.txt. Okay, so now here's people.txt. It is 36,662 bytes long. I can do more on it and I can start to see. Oh, there's a lot of lines here. It takes 2 or 3 screenfuls to move 1%. So there's a lot of lines in there. I can use head and tail, some commands like that. But what if I didn't want to have an intermediate file? If I was just doing a simple one-shot kind of analysis and didn't want to have to create a temporary file, I could do something like /l/home, and then instead of that arrow, using a greater than sign, like an arrow, to redirect the output, I'm going to do that vertical line character, shift backslash on the US keyboard. Um, some people, vertical line, other people will call it the pipe character. I don't know if it has I don't know which name is correct. Definitely in Unix, we're using this to create pipes, pipelines. We'll see this more and more over the next few minutes. Um, but what it's going to do here is it's going to take the output of this ls-l and it's going to feed that output straight into the input of another program. Okay. So I could take that and take the output of ls-l/home and push it straight through grep and tell grep, yeah, show me every line that matches the word Scott. Okay, so now my over 5,000 home directories, a listing of them, that will be 5,000 lines long. All of that was passed through grep, and grep was told, match, show me the lines that match the pattern Scott. So we got A Scott, E Scott, Scott BL, Scott S. Those match. So those are the ones that printed. The other 4,998 of them or something, they don't match, so they don't get printed. Um, This is referred to as a pipeline, and it can be arbitrarily long. So for instance, if I want to know how many lines or words or characters there are, I could, well, I'm not going to retype all that. I'm going to be lazy. I'm going to hit the up arrow key, and there's my last line. If I hit up arrow again, I get the one before that, the one before that. There's my last line. I'm going to add something to it. So the ls-l/home, I'm going to grep for all the Scots, and I'm going to pipe that through a command wc word count. Okay, when I do that, it tells me, okay, you have to know the format. It's in the man page. It's 4 lines long. There's 36 words, 277 characters. But the important part for me is that it's 4 lines long. So this kind of tactic will let you very quickly look through output files of things, directories full of output files. You can build these pipelines using ls and cat and grep and head and tail, things like that, word count. And you can do a lot of analysis without having to really go to a whole lot of effort. The tools are sitting here ready for you to use them. Now, when we looked at all the commands in that directory user bin, yeah, ls was a runnable program. PWD was a runnable program. We can write our own commands, taking shell command line tools like we've been looking at the last few minutes. We can write our own programs using those that do pretty useful things, right? So right now, say I'm in a home directory. I want to go into my bin directory. This is for programs that I've created as a user that I want to be able to run just like they were ordinary shell command tools. So I'm going to create a command. I'll just call it TTT, very creatively named because it's easy to type. And in it, I'm just going to do a few very simple things. I want to have it ls look through the home directories and tell me how many of those home directories contain the word Scott. Give me a number of them. So do a listing, pipe it through grep to get just those lines that match Scott, and then pipe that through wc to give me the word count. What else would I like to do? I could, yeah, have it print the date and time. That would work. And let's see what else I should have it end with. Um, okay, so 3 commands. We'll do the one where we count and see how many home directories contain the word Scott. We'll have it print out the current date and time, and then we'll have it do a listing of /home eScott Explorer. All right, so I can, oh, yes, exit. All right, taking a look here. We just created TTT. It's a regular file. These are permissions bits over here. They describe um, what other users of the system, what all the users of the system, including myself, I just created it, the owner of the file, what permissions there are. So as the owner of the file, I'm allowed to read or write that file. Other people in my group, chess, they're allowed to read it. And everybody else on the system, they're also allowed to read it. No one is allowed to execute it. Well, here it is, it's programmed, but we can't execute it. How about chmod for change mode? You just kind of have to know or memorize these. I'm going to set for all the different types of users, I'm going to add execute permission. And now there's these three X's so that now anybody can execute it. And lo and behold, when I run it, here's my 3 lines of output. It counts how many Scots there are with home directories. It prints the date and time, and it does an ls of the Explorer directory. Okay, so I can put as many shell commands in that file as I want to. And there are even ways we can add loops in here, and we can have conditional logic. You can write complete full-scale programs as these shell scripts. Um, it's a good way of dealing with file system manipulation, systems kind of work, some textual analysis kinds of things. I wouldn't write number crunching code with this. The ability to do math in here is severely limited. But it's good for dealing with using the operating system. It's a good way to do it. Now, there's something to keep in mind. The script right here does not specify what kind of shell to run in, and it doesn't specify any kind of programming language that it's written in. What it will do is it will default to running in whatever kind of shell the user is running, whatever kind of command line interpreter. 99% of the time, including pretty much always at chess, it's going to be a shell called bash. And it's pretty standard. I mean, it's just about universal. But there are others, and there are some upstarts that may actually displace it. ZSH, I think, actually will. So it's a good idea with any kind of script to make the very first line in this form. Okay, the first 2 characters are the pound sign and an exclamation point, and that says this is a script to be interpreted by something that can read commands, and the rest of the line is the fully qualified path / bin / bash to tell it how to get to the shell that's being used. Okay, I mentioned that here because in the next section, we're going to do the same thing again, but we're not going to be using shell commands. Instead, we're going to be writing actual legitimate programs in Python. And that's exactly how we're going to do it. We're going to put Python code in there, in the top line, we're going to tell the system, hey, when you run this, run it with Python. And we will be able to do anything you can do with a computer. We'll be able to do with a Python program saved that way. So this is a lot to digest at one time. It's in the course notes that are up on the training website. Play with this a little bit. Get kind of comfortable with it. Um, it's kind of thing that you're going to be using the rest of your career anyway, chess or anywhere else. This kind of the command line access to Linux tool-based use of the system is going to be basically universal.